Okay, today we are going to continue with that electromagnetism. Electromagnetism. Okay, we are going to learn solenoid. Okay, as I told you last class, I told you that I will demonstrate to you the solenoid, how it works. Okay, solenoid, and just a minute. Okay, solenoid. As we are going to learn solenoid. Okay, this is solenoid. Okay, this is important. That's why I'm teaching you again. This is important. This is very, very important. Okay, as a result, current is positive, negative. Current flowing here, flowing through here. Current is flowing through here, and here. Okay, current flowing through here, and the magnetism, magnetic field, electromagnetic field. This is current directions. This is current directions. Okay, this is current directions. Current direction. Just flow here, the front and then okay. And electromagnetism. This one is. Okay, this electromagnetism pattern. Okay, this is electromagnetism pattern. Okay, electromagnetic field pattern. In other words, electromagnetic field. Okay, as I told you, you have to do that. What do you call it? This is a solenoid. Okay, multiple turns of coil. Okay, this electromagnetic field in solenoid or multiple turns. Electromagnetic field in solenoid or in a multiple turns coil. Multiple turns. As I told you last week, is important, very, very important, because we have solenoid or we call multiple turns coil in electromagnet, in what do you call it, in a motor electric, in generator, so many things, transformer. So solenoid, basically solenoid. Solenoid means electromagnetic field. Okay, electromagnetic field in a multiple turns. So as I told you, this is we call it a solenoid. This is solenoid. Okay, this is solenoid. Imagine the battery is connected to battery here. Battery connected here, and this is a positive side. This is a positive side. The current is flowing here. Current flowing here. So this positive side battery, negative side battery. Positive side, negative side. So the current is flowing here, going up, down, and down. So we must use right hand grip rule. Okay. So current flowing here. Okay. Current is the yellow color. The yellow color says the positive battery. Connected to positive battery. So current must flow from positive battery. So current flowing here for positive battery. Current flowing here, and here go down, go to negative. So as a result, current is flowing. So it's important in solenoid. You have to learn current direction, and the coil must be front to back or back to front. The first turn for the battery, first turn for the positive battery, first turn from positive battery. You must see the wire is front to back or back. Okay, sometimes can come from back to front. So back to front, but here is front to back, so same like this, same like this. So front to back, front to back. So current is positivity, front to back, front to back, front to back, front to back, front to back. Back is quite negative. So, and you must use right and grip rule, right and grip rule, right and grip rule. Okay, this one is current going up. The four fingers shows current direction. Right and grip rule is other way. A and B. One is a straight wire. Electromagnetic field is straight wire. Electromagnetic field one turn coil. A and B. The one is different. Different. So that one is different. Both also using right and grip rule, but the first A and B, the first thing I taught last class, A and B is a electromagnetic field in current carrying conductor or straight wire, and electromagnetic field in a coil or one turn coil. So A and B, the one A and B. This one is C, solenoid C. Solenoid we supposed to learn first. Supposed to learn more. Solenoid A and B is not important lah. Question may come, objective or structure is not important question, but solenoid is very important, because from here we are going to learn so many other aspects. 3.2, 3.3 and 3.4. Okay, this one is 3.1. Okay, chapter 3.1. So 3.2, 3.3, 3.4 we are going to learn more things. Okay, and this one solenoid current is from positive battery. So current is flowing in. This current is flowing in. So front to back. So the current is flowing here. So this right and grip rule. Okay, unlike the first A and B, right? Straight line, straight wire, and one turn coil. Right and grip rule is a little bit different. Okay. And the right and grip, same right and grip rule, but in a solenoid is a little bit different, okay? It's a bit different, okay? This four fingers shows current direction. So front to back, and this one you must grip, front to back. So like this. So the thumb shows north pole. So we must write north pole. And this north pole, and this must be south pole. Okay, this is called electromagnetic field. Current flowing here. So it's four fingers grip. This one grip. Four fingers grip. Four fingers shows direction of current, and the thumb shows direction of north pole. So the magnetic field, electromagnetic field pattern start from north to south. This is north and south. So this electromagnetic field direction start from north and south, because we have found it north is this side, this direction. This direction, not this direction. Okay, so the electromagnetic field direction from north to south. So this is the direction of magnetic field. This is direction of electromagnetic field. Direction of electromagnetic field. This direction, this arrow shows direction of current. This arrow shows direction of current. This arrow shows direction of electromagnetic field. Direction. Okay. This one from north to south. If a north is found with this direction, okay. For example, okay, like this. Okay. Okay. Now this. Okay. Now this one, if let's say same positive battery here, negative battery here. The positive battery current flow here. current flow here from positive battery. The yellow is shows follow positive battery. Current from positive battery. Current flow here. Current coming from behind to front, because the turn is from behind to front. Just now the turn is front to back. But this one turn is from behind to front. So the current is that is front. That is. So this one, the current coming from behind, because this turn is different direction. Turn from behind to front. Unlike the first diagram, the turn is front to back. All this depends on the positive battery. From positive battery, the first turn front to back or front to back or back to front. Here's back to front. Current is flowing here. The current flowing here, flowing here. So the grip rule. The forefinger shows the direction of current. Current is this direction. Current this direction. Okay, and the thumb shows this direction. So north pole is this direction, and the south pole this direction. So the electromagnetic field direction is from north to south, this direction. So can you understand? Okay. This one we are going to do a question. We are going to do a question in the in the paper. I will give you the. I supposed to load this. I supposed to upload the question paper to you just now, the last class, but I failed to do. But I will upload the question paper to you today together with this lesson. So you will see some questions. Okay, this is objective paper. These objective questions. I will upload the objective question paper. This is structure questions. So this question I will do it for you today. And we are going to do the questions. Rest of the question we are going to do next class. So you must do homework. This question. Okay, question one. Okay, question 1. I will give this structure question. Structure question 1. This question, and I will give this lesson. With this lesson, I will give question paper together with the question. Upload the questions. Okay, you can see the question. You can see the answer for this question. Okay. Now, this question. This question, this is cardboard. This is now the cardboard. Okay, this is cardboard, and so the wire is disconnected with this. Okay, the question asks you: a student wound a coil of copper wire on the cardboard tube as shown in figure 1. Complete question A1. Complete figure 1 to show how you would connect a battery to the coil so that current flows in it. Use a standard symbol for the battery and mark the direction of the current in the coil. Okay, this is coil. So this is a battery here. Okay. Okay. I put battery positive here. Okay. Positive here. Okay. Sorry. One battery. This is one battery. A battery. This is connect a battery. So this is positive and this is negative. A battery, connect a battery to wire. copper wire. So this is cardboard, and the what do you call it, wound around copper, wound around cardboard is a wire, copper wire. This copper wire, this wire, this wire, this wire. Okay. Okay. The current direction is like this. Okay. This direction. Okay. Now, just now I want to rub. I doesn't want to rub, but I no place. That's why I wrote this one. Okay. Current is flowing here. Current is flowing is front to back. Sorry, back to front. This one, this direction. Okay. The current is flowing from front to back. Front to back. That's now I show you just now. It's not from front to back. The wire is not coming from front to back. The wire is coming from behind the cardboard. This one. This wire. This wire is coming from behind cardboard. This positive wire. This wire is coming from behind cardboard. Okay. And okay. And okay. And this is current directions. This is direction of current. So current directions. Okay. Next question they are asking you. Also in figure 1, draw the magnetic field lines around the coil. Use arrows to show the direction of the field. Also in figure 1, this figure 1, draw the magnetic field lines around the coil. Use arrow to show the direction of the field. Okay. The magnetic field, a solenoid pattern is magnetic field like this. And this is a magnetic field pattern, and okay, this is magnetic field pattern. Okay, this is a magnetic field pattern. Okay, how to find the direction of the magnetic field? How to find the direction of the magnetic field? Okay, so we have the direction of current. Current direction start from positive battery. Okay, positive battery, current direction. This is current direction. Okay, this is electromagnetic field. The electromagnetic field pattern. So electromagnetic field pattern also for direction. So how to find the direction? Okay, this one, the current is flowing here, and current is coming from behind to front. Something like this. Just now I show you just now. Okay, this one is a positive battery. Okay, this is positive battery. This is positive battery, and current is coming like this. Positive battery current like coming like this. From behind to front, and behind to front, and join to negative battery. So the current is coming from behind to front. So like this, grip rule. Current coming from behind. The forefinger shows current direction, grip, and the thumb shows this grip rule. Current is coming from behind the front, and the thumb shows direction of north pole. So the direction north pole, this is north pole, and this is south pole. This is north pole and south pole. So direction of magnetic field. So this current coming from front to from behind to front, something like this. Okay, like this. The current is coming this front. Okay, and north pole. Okay, north pole. So direction of the magnetic field start from north pole and end up in south pole. This is north pole and the south pole. This is north pole, North Pole and end up in South Pole. So this is a magnetic field direction from north to south, from this north to south, north to south, north to south. This is an electromagnetic field pattern, direction of electromagnetic field pattern. Okay, now we are going to do the question. Question B. Name the two factors that affect the strength of the electromagnetic field. State how each factor affects the magnetic field. Okay, this question, name the two factors that affect the strength of the electromagnetic field. Okay, the strength of electromagnetic field. There's a three factor actually, three factor. Okay, the first one is I forgot to mention just now last week. Okay, maybe running out of time because we're going to mention today. First factor. Affect the strength of electromagnetic field. Affect the strength of electromagnetic field. The first factor is current, magnitude of current. Magnitude of current. This is the first factor. Magnitude of current. The magnitude of current. How much current flowing. Okay. How the factor going to affect, how the affect the strength of electromagnetic field. Strength of electromagnetic field depend on magnitude of current. How is going to affect? Okay, we're going to write. They asked how state how each factor affects the magnetic field. So magnetic field current is a factor. Magnitude of current is factor. Okay, the how is going to affect. When the magnitude of current increases, the strength of electromagnetic field also increases. The strength of electromagnetic field also increases. When the magnitude of current increases, the strength of electromagnetic field also increases. Okay? Okay, now second factor is a number of turns. Number of turns of the coil. It's not number of coil, it's not number of coil, number of turns of the coil. Number of turns of the coil. So for example, this turn is 1, 2, 3, 4 turns only. But as a matter of fact, as I told you last week, there are few thousand turns. Actually speaking, solenoid got few thousand turns, 5,000, 6,000, 10,000. The more turns they have, the more stronger electromagnetic field. The more turns, but for learning purpose, be few turns. But actually, matter of fact, solenoid in what you call in transformer. This is the primary coil, secondary coil, transformer. We learn primary coil, secondary coil, few thousand turns, 5,000 turns, 10,000 turns. These are 3,000 turns, 5,000 turns. So we have more turns. The more turns and the turns very very close by. Very close by. That is very close by. Okay, the turns very very close by. And the more turns, you have more turns, more stronger electromagnetic field. So number of turns, how it would affect number of turns of coil, how it would affect when the number of turns of the coil increases. When the number of turns of the coil increases, the strength of the electromagnetic field also increases. When the number of turns of the coil, it's not number of coil again, number of turns of the coil increases. When the number of turns of the coil increases, the strength of the electromagnetic field also increases. Okay? Okay. Third factor, they ask you two factor only this question, but I will, as a notes I gave you third factor. Place soft iron core inside the coil. Place soft iron core inside the coil. Soft iron core. I'll teach about soft iron core next week, next class. But is a soft iron core. Soft iron core. This one, something like this. This one, soft iron core. Let's say soft iron core. Soft iron core. Okay, soft. Besi, keratan besi, lembut. Besi, lembut. It's not lembut, no. Okay, it's not lembut. It's something like this. We call it lembut lah, but it's not lembut. Okay. Okay, I'll explain what is besi lembut or soft iron in next class. Okay. Okay, if you place soft, imagine soft iron core. This one, you place soft iron core. It's an inside core. Inside. Okay. Okay. This one. Okay. If this place a soft iron core inside the solenoid, means it will increase the strength of electromagnetic field. It's a boost the strength of electromagnetic field. Why is going to boost or why is going to increase the strength of electromagnetic field? I will explain next class. When you study electromagnet. Okay. Okay. These are the three factors. Okay. Okay. We are going to learn the question 2a. Okay. I will learn out this one. We have few more minutes. This one question 2a. Question 2a. Question B and C you must do as homework lah. B and C homework, and objective question you do as homework. Okay. Okay. Draw. Okay. Figure 2a shows a vertical wire carrying a large current downwards. Draw in figure 2b. Magnetic field lines. Use arrow to mark the direction of the magnetic field. Okay. This one, something like this. This cardboard. This wire. Okay, this wire. And its current going downwards. Current straight wire. Is again A and B. Straight wire. Okay. Electromagnetic field in current carrying conductor or straight wire. And they asked to draw the magnetic field pattern. Okay. Okay, now this one X shows what? Current going downwards. Dot shows what? Current going upwards. So X shows current going downwards. So this is a cardboard. So if you put iron fillings, in this cardboard or paper, you can see the iron fillings should be round circles, electromagnetic field. You make a round circles. So asked to draw in this drawing block, okay. This one is this one like this. Okay, this is a electromagnetic field pattern. Okay, this one actual the structure, but this one is a symbolic drawing, symbol. Okay, this one is electromagnetic field pattern. Okay, now how the direction? Okay, direction of the current. Okay, this one straight wire must use a right angle grip pull. Unlike the right angle grip pull is solenoid. The forefinger shows direction of current, the thumb shows direction north pole. That is called solenoid. But this one we learned last week. Straight wire, current carrying conductor. Electromagnetic field in current carrying conductor. Current is going downwards. So that one, the thumb shows direction of current and the forefinger shows direction of electromagnetic field. That's a difference. Both also right angle grip pull. This also right angle grip pull. Solenoid, that's why we learned solenoid also right angle grip pull. But this one is for the thumb shows direction of current. And the forefinger shows direction of electromagnetic field. This electromagnetic field is clockwise and anti-clockwise. Is a clockwise. Okay, clockwise. This is anti-clockwise. Okay, this is clockwise. Okay, this is direction of electromagnetic field. Okay, this is wire current going downwards, current going downwards. Okay, these 4 fingers, the 4 fingers shows direction of electromagnetic field. Okay. Okay, with this I will end up today's session. Is all. We are going to do some questions. Okay, question you can have to do a question 2B, 2C, 2B and 2C. Okay. Okay, 2B and 2C, and objective question. You have to do all the objective questions. Okay, I will upload with you with this lesson, this question paper also together. Okay, you must do the question. Next class, next lesson, we are going to, God willing, we are going to see the questions. Okay, thank you very much.